Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over specifically numbers 27 to 29 on the SAT Practice Exam 1, Section 4, the Math Calculator portion. Usually when I do these questions, I first explain it. I first do the question real quick, and then I explain in depth on how I did the question. And so I'm going to go ahead and get started on number 27. So if you 10 by 10. Okay. Okay. Interesting. Okay. So, interesting. Okay. 1 by 1. Ooh, have to be careful about that. This is about 10 by 10. So I only get 10 of these 10 meters total just by the times 10. So this is be that. Okay. So okay, so my final answer for number 27 is C, and I'm going to go ahead and explain to you how to do this question. I do want to note that this question is tricky. The reason why is that it wants to sort of throw you off with a lot of these dimensionalities, and I had to read it and go through it for this specific question because I started realizing that this chart and the computation values would have obviously, what I did was I did 100 times 10 in the beginning, and I thought, okay, well, it's going to be about 1,000, and there's a little bit extra, so I was leaning towards B in the beginning. But afterwards, I started realizing because this is going to be a 1 by 1, each of these plots are 1 by 1, what this question is stating is that there's 10 students who have 1 by 1, which means this is total is just going to be 10 total meters. But in this question right here, when they say 10 by 10, there's actually 100 meters that exist. So this is just 10 out of the total of 100 that could be possible, which is why what you needed to do afterwards was to multiply that 1,000, that represents this total number of worms, or estimate of it at least, times 10 to order to get a more accurate value or guesstimation as to what would the value be. And so in the end, the value will be C. A lot of these type of questions do involve things you have to be careful about. At least for me, my suggestion is that if they give you provide you computation that involves meters and like sort of dimensionality based questions, you do want to be careful and mentally note that, and while you are doing the computation, so that you don't mess up on these questions. This is a type of question that I would actually suggest to do at the end. So what I mean by that is that I would suggest doing all the other questions that are faster to do, they're more computational basis, or very straightforward on their word problem basis before doing this type of question. Because in my opinion, this will be a question that will take a lot of time out of your limited amount of time you have on the SAT math portion. But that concludes my explanation for this question. And so I'm going to go ahead and continue on to the next question. So to continue on to number 28. So number 28. If system equation equals something like that. Okay, something like that. Okay. Interesting. It's possible. Which is not no solution. No. Okay. So for number 28, my final answer is C, and I'm going to go ahead and explain to you how I was able to get to this answer. So for number 28, and I'm going to write this, at least provide you a context as to how I was doing this question. So the quadrants are provided here in the image above. The part is that when I did the graphs, I guesstimated it. Because this was a positive graph at 1, it's somewhere here, the y-intercept then, I was able to sketch the line. I don't care whether or not the line is dotted line. This is an inequalities question of yes, you are correct. Like if you knew that, yes, you are correct. But it's not a question that I need to use that inequality so significantly or need to worry about dotted lines and whatever not. And so for this question, when it says y is greater than that, it needs to go upwards, because whenever the mouth is facing y, my shortcut to this is that when the mouth is facing y, I shade upwards. If the mouth is not facing y, I'm going to shade downwards. And for this question, upwards is going to be this side right here, because it is actually going upwards, right? And so that's how I was able to understand that part, and that's why I sort of sketched it real quick. Afterwards, it also mentions that y is greater than half x minus 1. So minus 1 somewhere around here. So I just guesstimated and sketched it out. Somewhere going through here. Be aware this actually will be a dotted line normally, but due to time purposes, I didn't care about that. And because I said it needs to be upwards, it's going to shade upwards. So this is my upwards because y is facing that direction. And if you see right here, I know it's a little bit not obvious right here, but quadrant 3 is involved into this graph. Quadrant 2 is involved. Quadrant 1 is involved. If you look right here, quadrant 4 is not involved. There's no overlap shading. This is my my overlap shading right here. There's no overlap shading at all that's going to be possible that's going to hit 4. And thus how I was able to get to the answer C. And that concludes my explanation for number 28. And so just to continue on to the last question that right here. Number 29. For a polynomial, okay, so I'm going to go ahead and get started on this. So, no, it's not going to be these two. Okay. So for number 29, my final answer is D. And this, I'm going to go ahead and explain to you how I was able to get to the answer so quick. So this is a more definition-based question. So what that means is that this is a polynomial-based question, understanding the properties of roots and how does, certain values represent certain things. At least for me, when I looked at this question, it said P of 3 and negative 2. I knew right off A was not going to be the case because that was completely irrelevant to this question. I don't see any negative 5 value or 5 value that's involved, and so I knew right off A doesn't count. For B, the important thing I noticed was that because it says this is equals to negative 2, it actually, when we create it into a polynomial format, has to actually be the opposite symbol value. So if it's negative 2, that's why I left C out for a while, because I knew that C, this could be relevant to this, and that's why I knew B wasn't going to be the case, so I took it out. But it came down to the point where I was thinking whether it's C or D. I wasn't too sure in the beginning, but there's a piece that's really important for you to remember. It's the fact that when they say x plus 2 is a factor of P, that means that literally there is a coordinate value of negative 2, 0 that does exist, or that exists in this graph. That means that there is some sort of x-intercept that does exist for this question. But this is not what it's stating. It's saying that actually it's going to be 3, negative 2. Okay, and so that's not exactly what this question is stating. What it's stating is that when we plug in a value, when we divide this by actually x minus 3, what's going to come out is a remainder of negative 2. And that's just a property that you do need to know about polynomials. But that being stated, if you did not remember that rule, the trick for me was that I could remember that this is representative of zeros that do exist. And that the only way it could be a factor is if it's going to be, factorable, it's a 0, it's an x-intercept of that certain equation. And thus how I was able to get to D. And that concludes my explanation for today. Thank you so much for watching this video. Please do continue to watch our other videos that are up so far. And please do like our Facebook page or subscribe to our YouTube channel. And we'll continue to make content like this. Hope you have a wonderful day.